Again, thanks for hosting. Always great. Looking forward for the tour. That's one more thing. When you came in, there should have been a place to mark that you're present. And then if you're going on the tour, that'll help. I think we're going to be broken into groups to make sure that we have that. So if you didn't do that, or you don't remember that you did that, when we have a minute or a break, make sure if you're doing the tour so we can make sure everybody gets to go that needs to go. And before the tour, we'll go through PPE and things to look for on that. Wanted to have in here the executive committee for the partners, all volunteers. Happy to do it, and I'm excited for the things for Indiana. Get to see a lot of the pollution prevention and sustainability. And so we have the tags with ribbon. Any questions or whatnot, just come find us. We can answer those. And thanks for. If our committee's here, if you wouldn't mind standing, just the group can see who that is. Okay. Thank you, Mike, represent.
The only one here.
Yeah, well, they're around, we're around for that, but yeah, feel free. Really, the spirit of partners is benchmarking, interacting, finding the best ways, new ways to do pollution prevention and sustainability. So everybody's free for that. Membership, we're at 99 current members. There are a handful or so actively looking at doing some applications. I think some are part of the tour part for that. So always looking for more, in different types. So on the webpage or here, you can go there to see who are members. If you know somebody that might be a fit, you could reach out to somebody on the committee. They can kind of get them some information, see if that'd be an interest. In general, it seems that there's a lot of people are really interested in doing that because of the benchmarking and being able to kind of share best practices for that. So do represent a decent part of the state, but you can see there's some areas, right, that we could have some more of our Indiana businesses and groups that could be partners. Can everybody hear me okay? Okay. Sometimes I'm too loud and sometimes I'm too soft, so I just wanted to make sure I was somewhere in the middle. So a little bit more on the membership. Of course, it's free and voluntary. It's a pledge to be in the program, and you have to have a good compliance record. So you can go through both for all companies for that. And then we have an annual APR. Who is happy that the APR season is over for this year? One more report for end of March, April 1 for that. So we'll have the results. All of those are being gone through to see the great success that we've had, both with our ESP and for partners for the year. So we'll be able to share some of the good wins soon when we've gone through that data. So some exciting, if you've been to virtual or online, and I apologize, there are a number of our partners online for that. So I want to welcome them as well. There'll be during the breaks some slides of time, showing a timer when we'll be back from breaks and different things, and then questions. Feel free to send questions and we'll get those answered, especially when we have the speakers for that. Apologize for not introducing at the very beginning. But we've shared that we were rebranding the Partners for Pollution Prevention to Indiana Partners for Sustainability. So we had talked about this in the conference last fall. For that, sustainability is more of an overarching, definitely pollution prevention is a component, a large component of it, but then it reaches also for more on there. So wanted to share that we have here on our left is our current today emblem, and then the rebranding is here on the right. So wanted to have it look similar, so it's identifiable, but new and refreshed, and have some more for that. So if you have comments or questions about that, I'd love to hear those. I've shared this before, why we wanted to change the sustainability, and I talked about the overarching pollution prevention is still a cornerstone for the Indiana partners, but it just gives us more, items for it. So another big thing, pollution prevention is a good starting point, but many partners are ready to do more. So a lot of us had a lot of low hanging fruit, right? Great things we could do. But by having it a little bit more encompassed, there's more, more resources or different things that we can do for it. More diversity and more different kinds of groups. We think we'll be able to reach and more members in all areas of the state. So some of the people that have shared in the interest, are in some of those areas I pointed out in the map for it. And then just more opportunities, business schools, industry, municipalities, services, and then also aid improving just the overall sustainability for Indiana. And then another good thing I talked about, the APR could increase categories and initiatives. We'll be looking at the APR, the committee. So there could be some other areas for that. So, so we have those opportunities there too. Networking. So we are working to do more of this. So if you could help grow this, these slides will be available. If you're on LinkedIn, if you aren't on the partners group, we'd love to have you. For that, the link's there. We've started a Twitter for that, and that link is there. If that is, now it's X, sorry. For that. So we'd love to see that and, share your stories there as well. So we really want to grow that more, use that option to reach more people and then share more of our good hard work. And if you if you'd like to invite business colleagues from either other departments or other companies to attend meetings, they're free to do and would love to have them. So sometimes it be just, another group hear something and then that works for them. And so we can have more outreach. And then we also distribute partners materials at conferences and meetings. So if there's a brochure in the back by Jean, and then there's a link if you wanted to see it electronic. So we are working to have both, but definitely everything electronic for us. Save the dates. So happy to see everybody for the first partners meeting for this year. In June, we'll be at Heidelberg Materials in Mitchell, Indiana. Soon we'll have that posted for registration. I can't recall if there's a limit like there was for this, but when you see the invite, if you'd like to go, it's best to sign up soon so you don't miss out for that. And there'll be a really good tour for that one as well. Of course, September is our 27th annual Partners Conference. And this year it's a little different. It is on Tuesday. It typically was a Wednesday. This year will be a Tuesday. So if you haven't, go ahead and put that on your calendar. And then in December, we'll do a virtual meeting. We did that last year in 2023. And we got mostly all very good reviews that people like that. December is very busy. The weather's unpredictable, especially, in Indiana, and to do it virtual. So the committee's been working hard and we have lined up for each of these a lot of good speakers, a lot of new topics, a lot of variety. So they'll be really good things. We're also working on for 2025. So here this next meeting, we'll be able to share some more there. If you're interested at your facility, your plant, your company would like to host a quarterly meeting, reach out. You can do the email or contact one of the committee members. Jean and the team are really good helping get everything organized, right? So you provide the space and the people to speak, right, will help with a lot of the things, but it's great to go to a lot of areas to see a lot of the good work. All right, so I want to thank everybody for coming today. This will be on, we like to do the evaluation, just to know what you think and, about good things you like to see, different comments for there. So this QR code will be up a couple times today. Or you can just, let me know and I can get you the QR code if you're not able to get that, but we would like feedback for there, if you're able to do that. Okay, so I wanted to introduce, we'll have Brajesh and Musumi will do a circular economy and life cycle presentation from Cummins. Want to have you, welcome, thank you.
Thank you very much. Good morning. Good morning. Can you hear me? Okay, back there. I'll try my best. I don't have that much voice, but I'll try my best to get up there. Looks like you all created some traffic on the road coming down this morning. I know Moushami is running late because of that. I think she had started about 6:30 or 7 o'clock, and she's just walking in. Perfect timing. Great to see some familiar faces here in the room, and I'm super excited that you all are here at this tech center. Welcome. Hopefully you'll have a great day and some of the sharing and learning that we have today. I can give a little intro about myself. I am Brajesh Krishnan. I work within the Technical and Environmental Systems Organization. So this is an umbrella organization within Cummins, where we have technical strategy around technical talent, emissions, and all those taken care. And we also have environmental systems side, which is around environmental sustainability, which is around facilities and operations, environmental management. Team members like Amanda, who is doing the HSC, the E piece of the HSC. We also have several aspects around production use, emissions reduction, CO2 reduction goals, and our work around circular economy, life cycle assessment, etc. So it's an umbrella organization. We work with all businesses, we work with all regions, we work with all site team members and cross-functional teams to really drive the work that we are doing. So we are not successful by ourselves. We need to work with others. So we just tell things and others help with the things. And I lead the environmental sustainability and compliance strategy. So as you all know, some of your organizations might be also, if you're having any operations in European Union or in India or in UK or in Australia, there are lots of different ESG regulations that's coming up. So we are getting prepared really for that in terms of how do we go to the next levels of sustainability journey. What we always know is, yes, we need to be energy efficient, we need to be reducing our waste, recycling our waste, we need to reduce our water use, but now it is going much beyond that. So how do we really have better visibility in our supply chains? How do we know what tier 2 is doing, tier 3 is doing, tier N is doing? We have a long way to go. So that is what one of the elements of my work is. And Moushami will introduce herself, but I get to learn a lot from Moushami about life cycle assessments and circular economy in other areas. So I'll leave to Moushami. And by the way, I've been here at Cummins for about 12 years and I live in Indianapolis.
Thank you, Brajesh. Good morning, everybody. Sure, there was some people had the disruptions in the travel, like I did. So I'm Moushami Mukhopadhyay. I've been with Cummins for 16 years. My background is in electronic controls, and because of my passion for sustainability, I moved in 2020 to our technical environmental systems and looking into on the product side, what do we need to do with respect to sustainability? So tools, processes, which is where life cycle assessment, what are the capabilities we need to enable circular economy strategies? What do we do in Cummins with respect to circular economy initiatives is what my focus is. So happy to be here.
Excellent. So we want to make sure this is a little maybe a conversational type also. We just don't want to talk to you. So if you have anything that comes up in your own experience, because we are all here to learn. I would not ever say that we know everything. We are continuously learning. We are continuously trying to improve. So anything that you have seen in your own operations, when you work with your clients, when you work with your other collaborators, please let us know what you have done, and also please ask questions. I don't think I need to go too much into it, but you might already know Cummins. We're a multi-business organization having global operations. One of the things that I feel very proud every time when I'm here working and engaging is the leadership that has been set by the company leadership. So when J. Irwin Miller was the president and CEO of the company, the vision that he had set across the importance of not just business as a business and the importance of communities and the societal aspects around the work that we do was really, really key. And I would say that was one of the inspirations for me also to start thinking about Cummins and eventually joining Cummins. And that goes all the way through our current leadership, Jen Rumsey, who is our current CEO. And she has been very vocal about how that connection between business communities and the overall services that we deliver is all connected. Before I get into the more details around circular economy areas, I would say our revelation or our journey started back specifically on the environmental sustainability larger strategy with a life cycle assessment and a hotspot analysis that we did back in 2011, 2012. This was done by MIT students, and they took one of our fast moving engines, ISX-15, and they did an LCA work on that. At Cummins, we have been doing sustainability for a long time. We have been having sustainability reports. We set our first GHG emissions reduction target in 2006, which was a 2010 target. Then we had a 2012 target. We had a 2015 target. But when we did this study, it was pretty powerful because it showed various pieces of it. When it comes to GHG emissions, it is our products is the biggest piece. Even though we have been doing a lot in our facilities, our products still have a big hold when it comes to the potential for GHG reductions. When it comes to water, you can see there, the water that we use within our own facilities is just only 12%. More water is used for processing of the minerals, making of the parts that ultimately go into the products. So when you really think about the impact that we can make by incorporating using less, using better, and using again principles, it's pretty powerful. You're making almost 8 to 9 times bigger contribution to upstream than our own processes. Same goes with waste. When you think about our own facilities waste, it is only about 19% when you think from a life cycle perspective. So every time we are able to right size a product, near net shape a product, we are able to reduce our own consumption of natural resources. Almost 4 to 5 times we are impacting upstream. That is very powerful when we think about it. So how much ever we think about, oh, let's improve our recycling processes. Let's make sure that we do our best efficient processes to reduce energy, water waste. We still have much more impact that we can make in our overall process. So knowing data was important. So all these and we all you who would have worked with Cummins, we love data. I love data. That is why I think I enjoy the role. When we think about these environmental impacts, how do we really influence more than what we can by thinking broader? And that really helped us in a way to think differently. We also were very well aware of the trends. When we look into this, we see that there is a lot of parts of the world where children breathe unhealthy air. There are extreme weather events, not just flood, but also drought, fire, everything that is happening because of the impacts of climate change. There are a lot of people who are living in water scarcity. I can say my own experience. I am from a state where we have 44 rivers. It's a small state in southern part of India where we have 44 rivers, full coastline, a lot of backwaters. But we don't have water just before the summer starts. So our wells all go dry. So when we really think about it, how can we collectively influence that? And obviously, the issue of plastics ending up in the oceans is the big one that we always see in the news, but that is because that is visible. There are so many things that is not visible that we can do something. So all this actually brought us together to Planet 2050, and you might have heard about Planet 2050 in various ways. The long-term sustainability vision and strategy that we have kept as a company, and our mission of making people's life better by powering a more prosperous world. We cannot say we have a prosperous world without society being healthy, without people having clean water to drink, without we managing natural resources in the most optimal fashion. So all these aspects were very critical to ensure that we are able to meet our mission. And when we think about the goals that we have set, and again, some of you might have already seen, we have 3 areas. One is our communities. Communities are better because we are there. We have an aspect around air emissions. How do we do our part in terms of reducing the impact on climate change and influencing air emissions? And also using natural resources in the most sustainable way. So we do have goals around it that are 2030 goals, which really drive some of the things that I was talking about in the previous slides around how can we make the impact. And the 3 aspects that I wanted to share here today as it relates to 2030 goals. One is around waste reduction. And you'll see that that's a 25% decrease in waste generation as percentage of revenue. What we have seen when we looked into our data is over the years when we as a company grew business grew, but actually energy usage didn't grow that much because we were doing a lot of actions to reduce our energy footprint, having efficient systems, lighting, machinery, equipment, test cell emissions, test cell diesel usage reductions, a lot of closed loop processes so that we are not losing that heat. Same with water. Actually, when we increased our business, our water usage, we doubled our business, our water usage went down by about 20%. So we already had a buckling of trend in energy and water, but not in waste. Waste was so correlated to the business. Business goes up, waste goes up. And that is where we were seeing how can we buckle the trend. And I'll go a little bit more deeper into that, what our strategy is, and that's specifically for our facilities and operations. How many of you are there who is part of a facility? Meaning you're sitting at a manufacturing location. Okay, what kind of roles? What is your role? What do you lead at the facility?
Oh, environmental coordinator.
You're an environmental coordinator. What is your role? Environmental program at the site. So you'll see that this really has a lot of these kind of goals will really be impactful from your perspective. How are you doing and reducing your waste? The other one that we have here is creating a circular life cycle plan for every part. And that you'll see that it is 100% that every part that we make, there is circular life cycle plan. And what we mean by circular life cycle plan is when you have that part, does it have a recycling designed into it so that it can be recycled at the end of first life? Is there a reman built into it? If it is not designed in early on, you're not going to remanufacture it at the end of first life. Is there a rebuilding or a repair built into it? There is a lot of things that we can do at the design stage. So this is really helping the engineers to think differently. And don't just put a part because that is the lowest cost, but think about all these things when you're designing in. So this is a fundamental way that we are trying to improve our designers thinking in terms of how to incorporate this. And the last one is around plastics. We all know that there is a lot of impact on plastics. We as a company doesn't have that much of plastics generated, but you see here today, you're here, you're using a lot of plastic bottles and cutleries and others. And how do we move away from that in our cafeterias and use more reusable or compostable type products? We also have a lot of packaging plastics. That is the shrink wraps and the VCI bags, which is the rust prevention bags that we use for our products and parts. How can we do better in that? So these are some of the short-term goals. I'll get into a little bit more deeper here. But one more thing that I wanted to leave, and I know Teresa is here. I know we have talked about this in the past about the Indianapolis Circular Economy initiative. I should say Jennifer Collins and others in IDEM really helped us with some of the conceptualization of this. How do we really bring communities and community members together to act on something that is broader than all of us? And as you know, in Indianapolis, we still do not have a universal curbside recycling. If any of you want to talk more and help more, we have relaunched that whole program now. There was a little struggle in between, but really we have an opportunity here. The RFPs are out. Actually, the RFP for the processing was out in March. I think it got closed in March. There's all the organics processing, the recycling, and also the regular trash processing. We also will have an RFP on the collection. What can we do to influence the decision making during that time? This is a perfect timing. So any one of you in Indianapolis, if you want to get participating and do your part to support how we can bring universal curbside recycling or universal organics collection, that would be best. Please let me know. I will switch to our facilities. So some of the things that I wanted to talk and show you about what impact we can make within our facilities and what are the focus areas that we have. But before I go there, any comments or questions, anything that I talked right now connect with you? Is that helpful? Any questions?
How do you balance the desire for a remanufacture or a rebuild with the need to reduce those natural resources coming in? Because as we've seen in history, some of the appliances that we had early on lasted a lot longer and they weren't going into the waste stream. And so is it that you're building better, stronger products that can be rebuilt, or, and you show on there, how do you balance that?
Yeah, no, there are different ways. And that's a great question. That's where we first think, should we actually, make it thinner size to reduce the natural resource? And by making it thinner size, now can you actually remanufacture or rebuild it or repair it? You have to use and throw. And we see a lot of that. And like you mentioned, our consumer electronics good or any of the home appliances is a great example of it. I still have a 25-year-old refrigerator at my home. Works fantastic. Uses about 4 kilowatt hours of electricity per day. I did all the math and it still says, let it run until it runs. Doesn't make any sense for me to change it. So very, very important. And I'm sure that Moushami can touch some of that also because she comes from the engineering side of things. But if I may say it in that way, that is how we need to balance to ensure that we are using the right materials. Sometimes by changing the materials, you can still have remanufacturing and rebuilding possible. Lightweight materials. Ensure that the suppliers who are providing that, they are very clear. This is our life cycle plan. It needs to be a reman product. And other pieces, how can we increase recycled content in those materials? So without even having any problem with the integrity of the part, you can actually still increase the recycled content in there. Some of our, or I would say a lot of our 15-liter blocks and heads, 99% of that of that is scrap. So how can we look at that? So there is that close looping of aspect of it. You don't have to thin size or right size it. But we also say right sizing is to a level that you can still reman it. One more point that I'll make, and I'll pass to Maushmi if she has some comments. We also have worked in our remanufacturing business to update the engineering standards in there. Because sometimes you're making a housing for a turbo and it says it needs to be an M8. And because it was an M8, once you actually rethread it, you don't get an M8 and you have to throw out the whole housing. But without impacting the performance of the product, can you actually extra size it, maybe M9 or M10? You can still use that whole housing, but then you change all the engineering parameters to make sure that the product still works with the same performance levels. So that has been a significant way for us even to increase our yield. Some of our yield increases has been tremendous, where we were having only about 13% or 50% yield to 90+% yield when you salvage those parts, when you update those engineering standards.
I think you've covered a lot, and you'll see some more when I go through my part of the presentation, but truly design thinking before product is there, at product conception. You start understanding the future with product conception. That's how you really address how it should function for closing the loop.
And there are lots of tools also today. So Creo is one of the tools that we use in our design function. And within that, we have partnered with them. Dave Gender, who is one of our engineers in the program, has worked very closely to have some of those learnings from our own analysis-led designs pulled in to Creo as a software, so that anyone who is using Creo can use some of those capabilities to balance where you draw the line.
I just have a follow-up question.
Sure.
So when you sell the product, then are you educating the people who are purchasing the product to the fact that you can rebuild or remanufacture?
It's a fantastic question. That is a big area. And again, I know Maushmi will talk about our remanufacturing business also as part of the circular economy. There is a lot. So some of our products, it's if you sell an engine to oil and gas, they demand it should be rebuilt and remanufactured, because it's a lot of cost to buy a new engine. So those customers really drive that. Same with a lot of other areas, whether it's mining and various other operations. Some of the locations or regions we have seen, they're very much bringing remanufacturing, may not be through Cummins, but their own local ways. So if you go to India, there are so many of them who rebuild engines all the time. They may not be, they might be a mom and pop store, but they still do that. Customer incentive is a big piece. So we have a way that we incentivize our customers to actually bring the cores back. So there is a core exchange that we get, and they get reduced price when they buy a reman engine. So there is a lot of incentives that is already built in. Actually, we are just wrapping up a project with Michigan Ross School of Business. And with them, we are trying to see how we increase that customer incentives and customer communication so that everyone knows, yes, today our core return is only, let's say, 20%. How do we increase our core return in a particular product category? But very, very important. Any other questions or comments? Yes, please.
Question in regards to upstream, sounds like you're doing a lot of stuff in training people or your customers. But when you go upstream, are you having a hard time getting some of the data from your suppliers?
Yes.
It is, yeah, the laugh is right there. We all, yes, we don't have that much of supply chain transparency, that much that we need today. That is, again, one of our biggest areas of work that we are doing. How do we engage with our suppliers to learn more about what they are doing? Or what can we work with them? And we are also culprits, I would say. We go and ask our suppliers to do a lot of things. Say, we as a supplier to our customers, we get now request a lot of things to do on certain things. And we all know when we have 100 things to do, that one more request is, it's going to be really tough. So how do we help in terms of evaluating the right elements? What is it that we need? So my principle is, always, why do we want to go and learn something from a supplier? What do we want to learn? So start with the why and the what. Don't jump with the how, because a lot of people jump with the how. Oh yeah, we have this new tool. We are just going to roll out this new tool and ask this 100 questions. And we don't even know why we are asking those questions or what we are going to do with those answers. So I think there is a lot that we need to improve. I was actually talking with someone yesterday, and I would say, when it comes to the supplier area, one of the models that I love, how many of you have heard about Chumek? Chumek, yeah, they're a HAS-based TSDF auditing organization, company, collaborator. I don't know what is the right model, but that is a membership-based organization where you can actually get your, TSDF lead report, just going there and saying, hey, I need a report on heritage facility in Indiana, and they'll give you the report. You just pay for it. They have already done a full-on deep dive audit at the facility. They, hundreds of pages of reports. If you have gone through it, very, very comprehensive. They will not tell you what to do with the data. It is up to us what to do. But that kind of a way where one organization actually go in and get all the data and then let it be a pull effect. Yes, Allison wants, Allison takes, Cummins wants, Cummins takes what they want and deal with it. Hopefully a model that will come in that way. I don't know how it will go, but maybe if there are collaborations happening in that way, we could potentially look at it that way. Any other questions? I know I can talk a lot. Comments? Okay, we'll get into the facilities piece, and for those folks who are in the facilities, you might see this data actually shows our distribution of how much of waste that we generate. Remember that 14% that I showed on that slide? That is what this is. So about 660,000 metric tons of waste, or close to I don't know in pounds what it is, but I need to do some calculations. I think it's about 800 or 700, 800 million pounds. Now I'm not doing that math in my head. But what it means is a lot of waste. We do generate a lot of waste. And most of the waste is in metal scrap. We buy a lot of products, we machine it, and we have the borings, then we have the scrap from the quality rejects, all those put together. About 50% of our whole waste stream is scrap. But we also have a lot of packaging, and I'll get to that in a bit. So what are we trying to achieve with our overall goal? So in our no materials wasted, our goal is, we always talk about zero waste, and zero waste is always, at least in my visibility, is put with a connotation that zero waste is zero waste to landfill or zero waste to, burn. For us, how do we get to zero waste? Full stop, meaning anything that is generated becomes an input to something. And that is where we don't call it zero waste, because zero waste, because it has a lot of connotations, we didn't want to get into that. So we say no material wasted. Everything has a home to go, that it can be repurposed and reused and recovered. Our current goal is 25% reduction. So that is that part that I was talking about. And because we have so much of metal scrap and packaging, we do have an opportunity. So where are we trying to do is to start with designing out. So if we are, again, right sizing or linear shaping, we have an opportunity there to not generate that much of scrap. If we are using more of reusable packaging, we have a great opportunity there to not generate that much of corrugated or wood pallets or wood skids or plastics. And then we also can look into our own manufacturing operations and improve operations by putting closed loop processes. In packaging, 100 million pounds of packaging we generate. We have launched a comprehensive program on returnable packaging at the company. It's it's a heavy investment, I would say, that the company has ever done when it comes to packaging. B, owning our own packaging, and B, supplying that to the suppliers. Suppliers can put it in there, put it back. We do the collection back, all the reverse logistics, inspection, cleaning, all those pieces within our own returnable packaging program locations. Huge opportunity that we are seeing there. It also can look into how we can not just reduce waste, but also supply chain optimization, because sometimes we have these corrugated boxes which you cannot stack it. So your cubing of your trailer is not happening. So you can also do some of the transportation and supply chain optimization if we do it well. The key piece here is if we do it well. But we have a fantastic team right now who is working on it, and we are really hoping that this would be a huge improvement for our company. Second one is manufacturing. So we don't generate as much of manufacturing and process waste, and this is the has waste that we generate, the rags and absorbents and the sludge and the coolant and the used oils and all those pieces. How do we have more reusable processes? So we have on-site some of the sites. I see Columbus Engine Plant team is here. So within there, we have a coolant recycling, on-site coolant recycling process. So we don't just, throw it out. So we have that constant process. How can we do it for all other liquids? And also we have several sites who are using reusable absorbents, some of the low-hanging fruits. I was at a facility last week. They are reusing gloves, and these are cut-resistant gloves, which there is a vendor who comes and takes it, brings it back. It also saves money. One of our facilities in New York, they save about $1 million on gloves each year by reusing gloves. So it is not just waste reduction, but also it's a huge opportunity for cost reduction. General refuse, and this is the everyday waste that we have, whether it's our cafeterias, whether it's our break rooms. How can we improve that? And we have an opportunity here also. So what we have done, we call it critical X areas within the company. So packaging is a critical X area, and within that we have several solutions, whether it's reusable packaging, right sizing, things like that. And within that we have currently within facilities and operations, when it comes to waste, about 30 different solutions that we are working on globally. So we have a consistent way of planning all the projects in a way that we can do it in a very efficient manner. And how many of you, and I'm sure some of you might have done, but how many of you have actually done a dumpster dive? Hey, that's my most favorite thing to do, and we have done this in various fashions. Even in the middle of the shop floor, put it all together, let employees do it, and let the plant manager lead it. We have done it outside our headquarters here. One of our VPs at that time, she had told us, hey, there is not going to be any aluminum cans in here. And indeed, when we did that, there were a lot of aluminum cans in the trash. So it was always a great way for employee engagement. So we see this particular goal in the general refuse as an employee engagement goal also. How do we really drive that engagement within our employee base and get them inspired to do better? So again, we have several things that are keys to success. And the first thing that I'd say is people. They are the ones who bring ideas. They're the ones who are really helping us on the ground to really help educate employees, but also put programs in place. And team members like Amanda has been really, really critical. We have a lot of programs and initiatives, and then we have a lot of tools. Some of the tools we have shared externally. So waste review tool, which is a very comprehensive tool that we use to understand waste, is something that we have actually shared externally. And now as part of IDEM's Clean Communities program, we also had a community version of that tool. I'm not sure whether it was published or not, but happy to share any of that if you would like to use those. So with that, I'm gonna turn it over to Moushami, but before going, Moushami, any other questions or comments? Was it helpful?
Yes.
Thank you. I think Brijesh really well covered the whole thing. I don't even think you really need this part of the conversation, but just to bring that definition, the actual examples back into the product, looking from cradle to cradle view, start with just a view. What is our economy today? We talk about a world, we talk about raw material extraction. It's immensely growing. Our demands are growing. We need extracted raw materials. The demand is so high that data suggests we'll need 3 Earths by 2050 to meet our requirements, our sustainability criteria. Is this really sustainable? As we know, no. So what does this mean? We have to change our today's work, today's means that Brijesh gave examples at each phase, all the way from extraction, sourcing, design, in production, use to end of life. What do we need to do about this? We have to look at a complete different approach. This is where the term coined was circular economy. This happened in early 90s definition perspective. It's not new, but over the years, the policies, the engagement, the community, everybody came together to realize that today's system, our linear system of take, make, use, dispose, is not really helping because the dispose is all going into a landfill or somewhere. And we don't know how long will it really take back to get into the earth. Sometimes it takes 2000 years for thermocol or something like that, as simple. So there needs to be a shift in that strategy, which is where a circular economy is something that was coined. The circular economy is intended to ensure a couple of things. One, that we close loop on the materials, minimal waste. So Brijesh has a vision, as he mentioned, to zero materials. But how do we get to that zero materials, minimal waste as possible, and you keep using the materials again and again is a critical attribute of circular economy. On the screen, I'm showing the definition that was coined by the European Union on definition. What is circular economy? But what does this really mean? It means that it's a system consider production, consumption, and how do you intake all those attributes together so that there is minimal raw material extraction, one, minimal resource processing, so the energy spent in converting into the product, and as an attribute, minimal impact to air, soil, and land. That means also a potential disruption or an environmental impact view where you're creating a better self-safe environment. So this is our comments approach, and this is where we fit very well into the circular economy definition. Because we already have defined through Planet 2050 strategy, use less, use better, use again, which are the principles very well integrated into the definition from the previous slide. How do we make sure that you're using the materials in the more sustainable way? Which means we start from product design. So to Jessica's comment, how do we conceptualize? We conceptualize to begin with product that we are working upon. In design, how do we design to ensure less is more? How do we ensure you're designing out waste? You're ensuring that you plan for remanufacturing, rebuild, reuse, and what are we going to do with the waste stream that gets generated? So there are tools. We start with an aspect of mass flow analysis in the materials domain, selecting the materials, identifying with sourcing, closed loop materials that could be used in a product, increases our recycled content, and thereby reduces our GHG emissions of our product itself. There are other attributes as well. We do life cycle assessments. We could do life cycle assessments to identify on a given product what are the critical areas to focus upon. In some cases, it could be the supply chain logistics, the production. The European Union studies that has shown in the last 10 plus years that the biggest 80% of emissions generated from the raw material, which means identifying the critical raw materials in your product is going to be very important. And that alone will not solve it. So in production, Brijesh gave a beautiful example going through the sites of the different activities. So in production, you'll have to consider about reverse logistics. How are we going to handle packaging? How are we going to handle the scrap content? How are we going to look at the assembly operations, the plant operations, secondary processing? All of these criteria play a critical role in this product design in production of the product with reduced greenhouse gas emissions, which then can be leveraged in use of the product, where we see the GHG for diesel, from a diesel product perspective, in use is where the emissions lies, not in a production. If you cut that plot that Bridget showed in the beginning, the product has a maximum GHG. You can cut a diesel engine product and say it's the in use where is the maximum impact because of the fuel type, the operations concerned. So there has to be a focus, which is why we have a focus goal around newly sold products. And then there is closing the loop initiative, which is looking at from the overall cycle, where are our areas where we could look with respect to rebuild, reuse, repair, and then expand that to ensure that we are able to drive the strategy for recycling where it's intended. There are more things that are currently actually mandating us to do this. European Union and other areas of the world, there are extended producer responsibility as regulations kicking in for plastics, for battery, for electronics, that will also make us or make the industry as an overall follow that path, which means Cummins by ourselves cannot do it. We have to collaborate. We have to work with the partners, with our ecological systems involved and our functional economy together. So it is not just one company, one person, supply chain upstream, our Cummins facilities, and value chain downstream. We have to work together to be successful, to get to our 2050 target. And I know I went through a lot. I can take a pause if you have any questions before we move to the next slide.
Does any of you in your organizations have a circular economy goal or practice going on right now? I assume Allison Transmission has some remanufacturing and others going on.
Elements of it, I think we're still working on the big, understanding and the various that we pursue, right? Just kind of link back, not just in the output, but all of the sides and then upstream, downstream, what we were talking about. So.
Anyone else? I know Honda has a lot, and we have actually benchmarked Honda a lot during our return on packaging program. And we actually use the same platform also, Surgier. I think is what you still use within Honda. That was a great learning for us in terms of how much of returns are happening. So any other work going on in any of your areas? Hopefully this will help a little bit, but if you see anything, please let us know also. We're here to learn.
Yeah. And truly, I just want to reiterate, this is a qualitative approach where we have to really consider eco-design as a principle. What is eco-design and how this will help us to design out waste, not only from the product, but the facilities, but the overall system that we are putting out in the market. So those are the critical principles. So I just wanted to give you another view of what are we doing in practice with the help of our Recon organization. Here is a review or a slide from our Recon team on what are we doing with remanufacturing. So with Recon, basically we are looking at products, we're enabling our customers to understand that we can provide a sustainable product. We're giving them a product which has an engine which is potentially 85% less energy than the original energy built product engine. You can see we have engines, sub-assemblies, turbo cores that we are taking. So that means there is this take back program. So this was some of the existing, community projects that we have to work with to ensure we can start this interface collections. We have scaled it for certain parts where we are able to see really growth. For example, we are able to manage about 70 million pounds of core, which is a very critical step in our mindset. There's a lot of value proposition also. This is not just environmental, there is actual business value to this. because it helps identify resilience, it helps identify reusability, it helps ensure that we can make it not just sustainable, but also there is a dollar economics value linked to it, which helps propose that. Which means, in summary, there are three great basic pillars that we have to consider in a product-driven, sustainable, circular economy world. The first pillar is determine your requirements. What makes this product circular? How do you drive that conversation? Two, what are the criteria involved? What are your indicators? What are the quantitative value targets against performance, against other pillars that you have already established? What would drive that? How much sustainable is that product that you're looking at achievable? What are the requirements? The regulatory landscape is growing immensely every day in California, in other parts of the states. New requirements are emerging right now. And finally, what about the supply chain? How can we make this more robust with respect to disruptions? We know since 2000, the supply chain raw material cost has gone over 100%. We know that there is enough, there is a lot of recycling that happens around the world for the heavy materials that we work with. We know that also supply chain is not just understanding those hotspots. It also means what are the weak spots? Where are critical attributes like critical raw minerals that are being used? Because there are requirements around that that's emerging. And hence it's important to enable those through the business value, through our community approach. So with that, that's the end of my presentation. If you have questions for me or Rajesh.
On circular economy strategy. So, in using or doing the cost for that versus buying new, a lot of times that would be, we found more expensive at times. How do you work with those to justify move to the circular versus?
It's truly driven by cost versus sustainability versus performance analysis matrix, because there's going to be criteria where how do you source? There could be sometimes an alternative selection methodology. There could be alternative design approaches. So it's truly dependent upon the region, the product, and the scope is how we have so far looked at it, because you also need to have a recycling facility close by. You also need a green material. If you want to resource a green material for a product, you want to make sure the supply chain is set up for that to be able to value it. Similarly, for rebuild, remanufacturing perspective, it has to be making sense from the connections, the operative value of the value chain, not just the conceptual value. So it's kind of, and that is why it starts in conception, as I mentioned in the beginning of the work.
Yeah, I think as you can hear from her comment, it's complex. But that is where if you're just starting, take small steps. Take a smaller part, maybe a small part, maybe one of the transmission that is your high volume transmission, and see what is it, where are the customers, how much this spread. If the customers are bringing it to a certain location, how much it's going to cost to bring it back, how much it's going to be the costing to disassemble everything, replace the parts that is worn out, put new parts, assemble again, put it into again factory quality, bring it back, how much that all cost. So maybe it's small, break it down into small pieces and see then the new part versus factory quality remanufactured part, what is going to be the total cost. And that is what you're going to then offer to the customer. Hey, by the way, you can actually still buy the same transmission, factory quality, remanufactured or refurbished at 30% less cost. Now you're creating a market, and you might be already making your margins there also if you do it well. And then it's all about scaling, right? And how do you multiply it? How do you get it into new markets? How do you get it to new customers? And how do you then bring that working together? The simplest one that, still not simple, but returnable packaging was a huge one for us when we did the modeling. Again, I mentioned we love data. When we started working on returnable packaging, the one metric that we started working on, we were hooked on to was McKinsey in one of the studies said average cost of packaging for a product is 2.9% of the cost of production, 2.9%. So, and that is the corrugated that you use, the wood that you use, things. Yes, obviously it range whether it's a small part versus big cost, but that's average cost. Now, if that can be saved, so you're not spending $100, you're now spending only $97.1. Can you use that $2.9 to actually put a returnable system in place? That was the model that we started working on. And believe it or not, that actually, if it all works, and I mentioned that if it works, it makes a lot of business sense and a lot of environmental sense. One example we worked on it. This is where LCA comes into place. LCA is a great tool to evaluate what model that you're putting. Yes, from a cost perspective, it might make sense, but is it also good for environmental sense? That is where LCA really comes in. One example, we used to use a different LCA software for packaging, and within that, one question that we asked, we wanted one of our operations in Australia, in South Pacific region, wanted to return all the engine skids back to New York. That is where it went from. So Jamestown, New York, we supplied all the engines to Australia, and they wanted to consolidate it and send it back to New York, about 7,000 miles of return. And it made a lot of sense from a cost perspective because the new skids were costing a lot. The return shipment was not that much. Obviously, during COVID, everything got disrupted. Not the same equation, but it all made sense from cost. Now, the question was, does it make environmental sense to bring all those things back? Does it provide more environmental benefit than cutting down new trees to make that wood skids to make new skids? And instead of that, getting it here and inspecting and reusing them. And within one use, actually, if you were able to use one more, actually it made all sense from environmental parameters, except for one. I think there was one which was around eutrophication. Again, I don't really understand what that means, to be very frank. But in that one, and also I think human toxicity, there were two attributes that I think was lesser in benefit. But if we're using 2 times, even that was possible. I think that was mainly related to the shipping emissions. So our answer was, now you can with confidence put a program together and say, not just it's a cost benefit, but also an environmental and health benefit.
And in that case, to that example, I was not part of the example, but I would assume that logistics plays a critical role because transportation by air versus sea has got a very big difference in numbers. So, the small thing on how you're going to collect, firstly, how you're going to collect back, how you're going to do the take back or the reverse logistics. The first element is the fundamental work also that's kind of drives that strategy.
Makes more sense. And again, if you need any help or you're a brainstorm, we're always here. We love benchmarking each other, and please let us know. I think we have 2 more minutes or 1 more minute actually. Maybe 1 more question. What do you say? Are you leading the whole program?
If there's questions, I would have a break, then I would certainly hear those.
I have one.
Yes.
So, you already respond, like writing the questions and then you responded. I don't know, you are ahead of that. But, one was, the role of innovation plays in your program. This, you already talked about this example, but you can do the same program in your site outside the US.
Mhm.
What difficulties or opportunities you have in outside the country?
It's a fantastic question. Not one size fits for all, right? You cannot copy paste the same thing all over the world and say it's going to work. Different external factors. I'm going to go back to the waste program. When it comes to waste, there are so many different external factors. One is regulations. So, Moshmi mentioned about EPR laws. So if you really want to put a circular economy business case together. If there is already a regulation that is forcing you to do that, makes it easy. And second aspect is technology availability. So in most cases, so when we think about, yes, Indianapolis, if we have a lot of trash, we don't have to send to landfill. Everyone sees, okay, it's zero landfill, but it's gonna go get to that Covanta facility for waste energy. Not available everywhere, right? So if you're thinking about what technology is available and what suppliers are available, because supplier capability varies quite, right? What is available here in the US or in the Europe may not be available in Mexico or in China or in India. So we need to be very, very thoughtful about how we design the programs to ensure that we have the best solutions locally available. In India, when we had our zero disposal goal, which was for our 2020 goals, we said no landfill and no incineration without energy recovery. So what are the options for those that are non-recyclable products? Yes, waste to energy was an option here in Covanta. Not every region had that. In India, we had pyrolysis, which was it was independent technology, but we did a lot of work with that vendor to understand how they do it. Did a lot of due diligence to ensure that we are comfortable with what they were doing there. In Mexico, we had more cogeneration in cement plants. So waste was going in there because again, there were some local regulations that favored that. Some other regions did, India didn't. Even though there were a lot of cement plants, there was no regulation actually prevented it from us sending some of our waste streams to cogeneration. So we had to actually work with our government relations team to work with the regulators to see whether we can improve. We've brought in examples from various other regions and say, hey, this is what everyone else is doing. Can we do the same in India? So those three, I would say, are the key factors: the regulations, the supplier capability, and technology availability. Anything else? Again, hope you have a great day of learning and networking and engagement. If you have any questions, we are available. You can let Teresa or Morgan know, and we can get back to you, or we can get on a call. Thank you all very much.
All right, I'll go ahead and get started with the next session so we can kind of keep on track. Thank you guys all for attending. My name is Amanda Hennessy, and I am the HSE leader here at the Cummins Technical Center. We're super thrilled to be able to host this and have everyone visit our site. We're super proud of the Tech Center. And of course, being a Tech Center person, we think it's the best Cummins facility. So you're at the right place. We are the funnest and the most smart and the best. So the Technical Center was founded in 1967. Construction actually began in 1964, but we were a pretty complicated site. We're research-based, so we treaded carefully, and we, as you saw, built 2 buildings, an office and a laboratory. So it took several years to fully construct the facility. Really the leadership of J. Irwin Miller, who Brajesh alluded to earlier, his vision for Cummins was very long-term. And when he cited the Tech Center, we were separate from the manufacturing because he really had the vision that research and technology and design and sort of that working together, that collaborative, looking towards the future was the way that Cummins was going to be able to sustain itself long-term. And I think we've seen that play out. Our facility is over 500,000 square feet of facility. We have around 1,200 employees assigned to the site. Obviously, I think everybody saw people working from home during COVID, and we see a lot of people still working hybrid, but we see about 700 coming on site to our facility any given day. We are the home for our most research and technology in Cummins. There are a couple of other technical centers globally as well, but we are still the main research hub. We have technical service labs. We have an Accelera labs. We'll talk about Accelera this afternoon and how they relate to Cummins, and our test operations that houses our test cells. We really fulfill J. Irwin Miller's view that collaboration between our business units and our engineers and our technicians and sort of bringing that all together really sets the tone for Cummins, and that's really still driving our site level mission today. Our facility is certified to a variety of ISO standards, 9,000, 14,000, 50,000, and 45,000. So the main thing that the Tech Center is known for is our test operations. So pretty much every engine type, except for the really large ones that they do in Seymour, comes through the Tech Center at some point, either in design or testing. So we have 89 test operation test cells. 8 of those are 1065 compliant CVS cells, which means that those are the cells that we use to certify our engines for compliance for the US EPA. They also certify for other countries as well, but all of our EPA certifications come through those cells. We have test cells capable from 100 horsepower all the way up to one test cell that is capable of 3,000 horsepower. We do run a variety of fuels, including research fuels. So that can really be anything that anybody dreams up, because like I said, we're the smartest. So we got some ideas. People have crazy ideas of what they think might fuel our engines in the future, and we design and try those. So a lot of work on us as the HSE team. We have a build area that prepares engines for testing and then also receives them after testing. So if an engineer wants to look at parts after the test is completed, that happens in that build area. So we have 18 bays that receive and send engines to those test cells. We have groups that do instrumentation and emissions support. So when you go on the tour, you'll see that each test cell might have a bunch of purple lines in there, and they might have, cords and tubes coming out. So we're always looking for all kinds of data from that engine. So we have entire groups of staff that are designed to set that up and take it down and receive all that information. The test operations group has about 350 employees, and they run 24/7. So we have shifts that cover weekday nights, and then we have weekend shifts as well. Outside in a separate building, we have an electrified power lab that have 5 test cells that are dedicated completely to battery, traction motor, and power electronics. Those are our newest cells, and Matt will come talk about those this afternoon. We have 1 environmental cold cell that is capable of testing at negative 40 degrees Celsius. We have 2 altitude test cells that can simulate 10,000 foot elevation. And then we have 1 angularity test cell, and that means that it can shift and rotate to mimic an engine at different angles. So before I came to the Tech Center, I wasn't entirely sure what a test cell meant. So I thought I would, in case there were folks that weren't familiar, take a second, kind of explain. It's basically a room, a small room. Sometimes they're bigger rooms if you're having a bigger engine, but ours are sort of a smaller size. We have a dynamometer that's going to receive and give power to that engine, the engine, obviously. Other inputs include fuel and all those support processes. So it depends on what we're testing, what those support processes might be. So here at the Tech Center, we might receive an engine from the field that's having trouble and we want to troubleshoot it. We might get a customer complaint. We might have an engineering group, either in the research or in the engineering teams, that want to try something different or want to understand what's happening to our after treatment. So engine emission limitations are very strict around the globe. And so we're always trying to minimize our emissions. And so a lot of our testing is done looking at how can we change parameters to improve our emissions performance. The actual test process itself. So once an engine's in the cell, it's all set up with the right facilities, the right fuel, the right data that we want to collect. The technician works with the engineer, works with the equipment, runs the test. Again, the test could be a 1-hour test. We could just want to know one little thing and we just run it and get the data and we're done. Or it could be a test. We want to know what happens to this part after it's run for 2,000 hours. So it just completely varies based on what the engineer or the team wants to know. So the test happens, and then when the test is done, we have that information, the data that we've collected from the instrumentation. The engineer has their information, and then we can also take it to the build area, tear it down, and be able to just look at the parts. So those tie nicely with the other big part of the Tech Center. So the rest of the Tech Center are our technical laboratories. And again, we'll have somebody from the laboratories come talk briefly this afternoon before the tour. But we have a lot of labs that do a variety of types of research. And I won't go into each of these in depth because there's a lot of detail, but they could do basic chemistry. They might be looking at the oil to understand, are we seeing degradation in the oil? Are we seeing contaminants in the oil? They could be looking at after treatment. So we have a lot of after treatment on our engines to meet those emission standards. So they might be looking at after treatment. We have a noise cell. You can kind of see here that absorbs the noise, and we're looking at making sure we meet noise standards, understanding what the noises are coming from our engines are. We have a metal 3D and a resin 3D lab that works on, how can we provide custom parts for testing. So a variety of things that take place in the laboratories. So I figured, see, from an environmental perspective, something that we deal with every day, right? You're gonna want to know who we are and what we do. So we have a Title V air permit. So we are minor for PSD. We take a limit, we report our emissions to maintain that minor PSD permit. We have a pre-treatment permit on the wastewater. We do not direct discharge. We discharge to the city of Columbus. We're a small quantity generator. And Burjesh in his presentation earlier talked a little bit about our shift from that theory of looking for non-landfill to that complete waste reduction. But at the Tech Center, we were able to obtain 98.4. I didn't want to give ourselves that extra credit by rounding up, but I really wanted it. I wanted 99, but 98.4% non-landfill from the Tech Center, which I'm pretty proud of because I think from a manufacturing facility, a lot of them have reached 100. But at the Tech Center, things change daily. We're getting things that most people don't see. So for us to attain 98%, I was pretty proud of. But we're now switching gears to that kind of more life cycle and looking at our new targets are no longer directed at non-landfill. Now we're looking at how do we just reduce that waste generation entirely. On the environmental management system side, one of our biggest environmental aspects is spills and releases. We have a lot of fuel here and a lot of laboratory chemicals. And so one of our big things that we try to control and focus is spills and releases. How do we make sure that we're not releasing things? How do we make sure that we know all of our fuel is being managed in the best way it can, and that it's only being used in the test cells and not released otherwise? Looking at sustainability, we are one of the biggest contributors in all of Cummins to water and greenhouse gases. So we've embarked on some pretty aggressive water reduction projects and some energy projects. We've been much more successful on the energy side, and that's really driven by the switch in our products. So Burjesh talked about those goals for 2050 and really trying to improve the performance of our products when it comes to greenhouse gases. And so we're seeing that start at our facility, right? We're testing those alternative fuels. We're testing batteries and hybrid, so we're seeing less fuel consumption. So a lot easier for us as the research facility to start making progress in that emission. Water, we've had more of a struggle. We were well headed down in that direction, but as we've added capability and all those other alternative fuels are still generating heat, most of our water consumption is driven by cooling. And so we have much more struggles in trying to meet those targets for reduction on the water side because we are still seeing the cooling demand. So how do we work on these projects and how do we get there? Well, we have a very great environmental council. So this is something that probably a lot of you guys have at your facilities. You have a team that's working on projects and improvements. And so that's really where CTC has made all of our project improvements. So we've got a great team. This team does our energy review, our water balance, our waste review. They set all of our KPIs and targets and they follow up on them and really drive them. They help support training and operational controls and then implement a variety of projects. So some of the projects that we've done here in the last few years at the Tech Center include LED lighting upgrades. So we already had fluorescent lighting. So actually to get that money to improve to LED, we had to really push for it. So it really took this team getting behind it saying, okay, we're already pretty good with the fluorescent bulbs, but we can do better. Let's go ahead with the LED, even though the cost benefit isn't quite as great as when we moved to fluorescent. We're working on adding a lot of controls on equipment. and to try to better control things rather than manually and wait for testing. So for example, our boiler water, our air compressors, all those things, we've had projects related to improving our controls to manage those. So they're much more demand-based rather than just trying to maintain a certain level. Metering sounds super basic and doesn't justify a lot of actual hands on the ground savings. But the more metering that you can add, the more you can see the benefit of your projects and you can identify where to do those projects. So CTC has a ton of metering. We can tell our energy use down to the area very easily on a regular basis. We've also implemented a lot of water reuse projects, a lot of condensate collection, verifying we don't have any ones through cooling, and try to really reduce our water consumption. Probably the biggest improvement project that we have done over probably the last 10 to 15 years is the continual implementation of regenerative dynos. And those are part of our equipment in our test cell. And so I'm going to have Sam Mayer, who's in our test technologies team, come up and explain kind of what regenerative dynos are and how they've helped us improve our performance.
I'm Sam Meyer. Romero was actually supposed to present this, so he had a conflict, so bear with me. So on the regenerative dynos, so kind of what we're going to go over, kind of the basics of the regenerative dyno, how it works, just to kind of get an idea of where the energy savings is coming on, the electrical consumption of kind of a dyno, what we have, and water consumption of those dynos as well. We have two types of dynos. We have the eddy current dyno and then the motoring dyno. So a motoring dyno basically uses an electric motor to either drive the engine or take the power out of the engine. So if you think about driving down a hill, you're in gear, the car is pushing you down that hill, right? So that's where the electric motor is driving the engine. So that's how we simulate that with a motoring dyno. In an eddy current dyno, we don't have that ability. All we can do is try and brake the engine to try and slow the engine down. So those are kind of the two type of dynos we have. So this is kind of a diagram of the eddy current dyno, I'm sorry, the motoring dyno as it comes in. We have electricity that comes in from the grid. You see the sine wave there is kind of what we call dirty. It's noisy. It doesn't do well for controlling the motor as much as we would like to. So what happens is that comes in from the grid to the regenerative portion of the dyno. It's transformed into DC, and we have an inverter. Since it is nice and clean when it goes through DC, we can make that into a nice clean sine wave on the AC power, and then that power runs the dynamometer. So this is a regenerative one. On a typical one where we don't have any regenerative, it does the same thing. I'll show you here in a minute. Instead of taking power back into the building, there is basically a big heater. So the energy when we're braking the engine, trying to slow it down, comes back out, and it's got to be released somehow. So the way we release it is through heat. So the energy to slow it down runs through these heat resistors, and it just creates heat if it isn't regenerative. So in the regenerative portion, basically, like I said, running down the hill, this dynamometer acts as a generator now. So it's producing electricity. So it's producing the AC current and voltage that's coming out, and everything works in reverse now. So we're now changing that dirty or noisy AC going through the inverter. It inverts it into a DC voltage, and the DC voltage goes back to be used. It's actually kind of nice because the AC voltage that this produces is a lot cleaner than we get on the power grid. And sometimes this helps some issues we've seen around our test cells where we have dirty AC coming in, and we have issues with certain modules and things that just don't respond well to having noisy AC. So, that's kind of the way it works. And like I was saying, the energy in a typical non-regenerative, there's basically a resistor that comes across here that produces. So not only is that wasted energy not used, it just produces heat. We also have to cool it, right? Because it's produced and we have those boxes downstairs in the basement. So now the basement's getting hotter. It's great in winter, but in the summer, we're also now having to reduce the temperature down there, which is that extra load on the cooling towers and all the cooling systems. So we're using more water, more resources to try and reduce the temperature and to get more utility. So we have questions on any? Does it all kind of make sense? Okay. So this is our energy usage that we have. I'm just gonna go with January for easy. So we have a 2.5 million kilowatt hours of usage in the tech center in January. Of that usage, about 400,000 is, we say put back. Basically, we are using that because instead of purchasing it from the utility company, we're taking that energy when it regenerates and then using it throughout the building. So this portion is not putting a load on the utility lines and upstream. So our overall, the average, I think, is from 11 to I think it was 17%. The last 2 months there, November, December, not sure why, but we're much lower. But I think overall, the whole average was 13%. So anywhere from 11 to 17, and then those two lower ones there. Currently, 70% of our dynos are regen dynos. As Amanda had said previously, we have 88 test cells. So of those, we're gaining this benefit.
That's essentially like the energy recovery from burning the diesel fuel, right?
Yes,
The motor's
exactly.
running with diesel fuel and you're just capturing the energy generated by the motor with the resistor.
Exactly.
From the dyno.
Yeah, so it's basically a power gen, right? It's an electric, or it's a diesel engine running a generator, and we're using that energy.
And the dyno is also measuring the performance on the motor, right?
Correct.
It's like, this is just while you're testing the motor.
Yeah,
you're
yeah.
Capturing that. The power
Yeah.
from the motor.
So yeah, if we're whatever testing we're doing, we're trying to load the engine to say a simulation of it's pulling, whatever up a hill or just on flat land, right? We've got to put load on that. So that load is being transferred back. All right. So next portion is, you see it's just bullet points. The slide's not well put together, but so water consumption. So kind of the eddy current portion of this. So before I mentioned that when we load the motoring dyno, we produce heat. Same thing with an eddy current. Instead of using a heating grid that just produces heat into the air, we heat water. So the water is heated, and that's what takes the energy out to slow the engine. It creates the drag basically. So a dyno consumes about 10 gallons per minute for 100 horsepower. So if we're running, just for as an example, 250 horsepower engine for 1 week, 24/7, obviously, if it is continuously running, which some of them do, we try to get as much utilization out of any of our engines as we can, because we don't have enough. If we have a 1,000-hour test, we need to make sure it gets done as quickly as possible. So we try to run them as often as we can. But just for example, if it was 250 for 1 week, we're at 252,000 gallons. Just to put that in perspective, the average family uses about 2,100 gallons a week. So, and again, these gallons aren't just dumped, but they are heated because of the dyno, and we have to cool them. There is loss through evaporation, but that's how much is flowing through our system for one dyno. And kind of as Amanda had mentioned, we are now at 70%, a majority of our dynos of the 88 or 89 dynos. We are now at 77. 2006, we were about 10%. So we have made a large stride in moving on to regenerative dynos. And that was all I had. Does anybody else have any questions? I'm good.
Great. Next, we will have Suzanne Guama from Cummins talk about our projects related to environmental justice.
Good morning, everybody. I mean, it's almost, but it's morning. Suzanne Guama, thank you, Linda. And so a lot of my work is on how do we make effective decisions using data, specifically using computational methods. So when we look at climate modeling predictions or we look at AI. And we use this with environmental justice because actually, how many people have heard that terminology, environmental justice? Okay. How many people think it's vague? I do. Right, like what are we talking about? Like what environmental part and what justice part? I think that a lot of times we talk at the level of principles, and that's pretty discrete from processes. And so it can be hard to understand, like, yeah, we're committed to environmental justice. We're not trying to pollute poor communities, like disproportionately compared to wealthy communities. But what does that mean in our operations? And so that's what I'm going to talk to you about today is what is our policy at Cummins around environmental justice? And then how are we actually developing processes to make sure that the environmental benefits and burdens are equitably distributed amongst low income and other communities? This is clearly a work in progress. I'll be sharing with you what we've started, but I do want to encourage you. In a former life, I was a professor, so I do like the sound of my own voice. Please interrupt me and be like, hey, can you back up? Can you clarify? I have a question. Don't hold it off till the end because sometimes you lose your thought. Cool, we're good? Okay, we have a lot of goals, right? So far, these goals are not specific to environmental justice. And so what I do is I look at these goals, like when we talk about things like our products or our facilities, or when we say net positive impact, what does that mean? When we talk about our actual strategies for how we achieve these goals, how do we incorporate the interests of those communities where we operate? So if they're better because we're there, better according to who? Right. So I had worked previously with the city of Gary, for example, Gary, Indiana, and there are very clear interests within that community that are both economic and environmental that are very different than somewhere like Columbus. So when I was putting together the climate action plan in Gary, that looked very different than Columbus. Cummins' impact in these communities is very different as well. So the first step is to better understand with communities, what do they think is better? What matters to them? Because that's how we measure our success, that they are better off because we're there. Community-led Cummins powered matters because what I just said reflects a stakeholder model. Who are the key stakeholders in these decisions? When we're talking about our facilities goals around environmental targets and goals, what are their thoughts? What are their values? Making sure that's incorporated, not just in terms of town halls where we all get together and, oh, that's so nice to hear from you, and then we all go home. Right? A lot of times, or it gets into a document or a Zoom recording that no one watches. No, I need to, as a Cummins representative and in terms of our facilities and processes, make sure that your changes are reflected in our actual decision-making procedures. So why should we care about it? One reason you might care about environmental justice is from a regulatory perspective. It's increasingly being driven for granting. So if you apply for any grants from the Department of Energy, you are now required to submit a Justice 40 section where you show how 40% of those benefits will be going to low income communities or disadvantaged communities, direct or indirect benefits. So a lot of DOE grants, you have to be familiar with this kind of terminology and how do you make those calculations. On the flip side, though, there's also now a Department of Justice enforcement strategy for EJ. Environmental justice is now a risk. It's a risk factor. It's also a value. But how do you mitigate that risk? How do you manage it? If you don't have the data around where your facilities are located or what the environmental impact is and the demographics of your community, you might have a disproportionate impact that's completely unintentional and that you might be unaware of. So getting the data on those risks and having a clear risk mitigation plan for environmental justice is really high priority for us. Now, there are a few trends that I'll share with you. This is a lot of text. I think, was it Sam who said that was a bad slide? I think this is the worst slide. My apologies. First part is, a lot of the stuff around environmental justice does include economic justice. They go hand in hand. Workforce development, training opportunities, all of those are really important. Two, we have to make sure that the federal investments are going towards these communities. So a lot of times we have investments for R&D, for example, what I think Amanda was just talking about the research that happened here at CTC. A lot of that research can be funded by the federal government. So that's why we need to start thinking about how that impacts our communities. Air quality and public health are the two major points. If you're thinking environmental, my first question, what part of the environmental impact matters? The part that affects people's health. We're not talking about like polar ice caps in 50 years. Maybe you care very deeply about that. I'm going to be frank, that's not my concern. People who are inhaling poor air and who are having asthma and who don't have access to healthcare, that's the highest priority at the moment. So if you're thinking about where do you start, that's where you would want to start. Next is that you want to make sure it's data driven. So you want to make sure you look at the available screening tools that the government has put out, as well as the private sector, to understand what are the demographics and environmental impacts based on sensors, based on metering, based on direct measurements at your sites. That's the best foundation for coming up with a strategy. Okay, so we came up, the first step at Cummins that we did was put together a policy. What does this mean? What are we committing to? This is the communication folks like this, right? High level. We want to increase the benefits. We want to make sure we're innovating products that are cleaner. We want to partner with our communities. Now I want to talk about how we're implementing this. First step was putting together the risk mitigation framework. Let's first look at all of our sites. Where are these sites located? How many of them are in low-income communities? What are the environmental impacts of these sites? Are there any trends? And you will find that systematically, and it's not just for Cummins, but across the board for industry, that a lot of sites with high environmental impacts are located in low-income communities. So first, understanding that type of risk is important. Then the next part of the framework was putting together, okay, so what are the steps? How are we going to work with the community to address those risks? This is that community-led Cummins powered part. How do we do that? You don't just come into a community and be like, hey, folks, why don't you tell me what's up? What do you guys care about? How are we affecting your community? Do you breathe well? Right, so we have to actually put together a plan about how do we build trust with communities, and that takes time. There's no shortcut. It takes time. We've been doing it over time with different sites. We started with Memphis, actually, was one of the key sites, but where are your highest risks? You probably have a whole team dedicated to environmental risk management. Work with them and collaborate on them. Send me your list of high-risk sites. I'll look through and see which ones have environmental justice impacts. Then we'll see who are our community partners in that area. What relationships do we have? How can we start building that trust to develop a plan to move forward? Rajesh threw up this slide earlier. We have similar slides here. These are the goals in terms of reducing scope 3 emissions for newly sold products, for example, but also what about our emissions from facilities and operations? It's not just the number. You don't want to just reduce 50% of those emissions. You want to make sure you're reducing a significant portion of that in low-income communities. So that's a little bit of a difference in this goal, right? Similarly, when we talked about, and Burjesh mentioned this earlier, with packaging, with waste, with water usage, are we making sure that those reductions are also prioritizing low-income communities? So I'm going to show you one of our processes, just so you get an idea of what this looks like in practice. First, and this is just a screenshot from what it looks like in my work plan. So get a site of all of your sites and then go through the screening tools. There's two of them. There's the EPA's EJ screen, and then there's the White House Climate and Economic Justice screening tool. They're both a little bit different and they're both used for enforcement. So you want to check both. Look at all your sites. How many and which ones are in low-income communities? Then we did a data analysis. Look, for all of these sites that we have environmental projects there, and they have impacts. We have like water savings projects, diesel savings, electricity savings. We invest also a certain number of environmental capital expenditure. So last year it was about $35 million that Cummins spent on environmental projects at our sites and facilities. That's a huge and significant number of projects. How many of those are in EJ communities versus non-EJ communities? What's the ratio? So that was the next part of our analysis so that we could better understand our current impact. Then you could set goals. 2024, if we hypothetically, right, off the record, if we had 46% of our greenhouse gas reduction in low income communities, which is awesome, by the way, what's our goal? What's a reasonable goal for us to set for next year? 50%, 55%? How do we achieve that goal? We have a prioritization process, existing process. It did not include this element, right? So it included things like waste impact, water impact. So let's say a site comes to us with a project, hey, I want 150K for these lighting projects. Now, instead of just prioritizing it based on these criteria, we've included environmental justice as an impact with clear and measurable metrics on the scoring criteria. And when we're prioritizing our project for this year's capital, for the 40 million for this year, about where that goes, that's going to have an impact of 7, which is pretty significant. It's not just that it's low priority, it's pretty high, and it can tip the balance so that in the end, we make sure we're prioritizing projects at sites and communities that are disadvantaged. That helps us achieve those goals that I talked about. We don't just have 50% in greenhouse gas emissions reductions, for example. We want to be able to say we have that in disadvantaged communities specifically. Okay, this is the fun stuff because AI is all trendy and, you know, that's also my research area, which if you want, I have a new article coming out that I'd love to share with you. And is that self-promoting? That's self-promoting. It's okay. So how do we try to incorporate some of these tools beyond some of what we've been hearing with respect to like AI taking over the world? More specifically, there are ways that we can incorporate it with our sustainability initiatives that could enhance or augment our existing goals. How do we track this stuff? So when we're talking about environmental capital, is there a way to now automate that screening for us, for our sites? And then to develop what's the calculation, what's the data from historical data, what are the trends moving forward, and what are reasonable targets? So that somebody doesn't have to sit there looking at Excel files for like 12 hours a day for a week. So a second one, supply chain management. This is really high value. We talked about earlier with Moushami about life cycle assessment, circular economy. I'm used to really complex things. When I was learning about supply chain stuff for Cummins, I was overwhelmed. It is incredibly complex. It's difficult to get that data from your suppliers. It affects every element of your value stream. How can we leverage these tools to look at these massive amounts of data, including public data, public reporting data, to get information about our suppliers so that we can now use it to track what is the environmental impact across that value stream down to when we ship out the product to the customer. That's a really cool use case that we're exploring right now and putting together the business case for. But I want to highlight it because it's a huge opportunity and it's something that I know Microsoft and other companies are looking at really closely. For sustainability reporting, you probably have to put together these different reports for, you know, CSRD, for Europe, for the US. And a lot of it is like the same question every year, but a little differently. And it's pretty extensive and it's content, it's words. So generative AI, things like ChatGPT, I'm not telling you to use ChatGPT, but that kind of model for AI could be really useful for trying to populate and come up with these sustainability reports year after year that's consistent with your existing content and material. So you don't have a problem where one team is preparing one report, another team is preparing a different report, and they're giving different information. Or that the sustainability reporting team is providing certain data that maybe a different team that works more maybe on internal operations is providing. Another part of it that would be important is for risk assessment. Oftentimes, people have pet projects, they have, you know, their favorite, you know, facility or team or whatever that could impact some of the values that inform your risk assessment. Risk to who and how much is that risk? Is it low, medium, or high? A lot of times these are individual judgments, like you and I saying, hey, look, this is actually a pretty low risk, you know, project at this site. And you can benefit. You can benefit from my expertise or from your expertise. But it would be really good to also have some sort of independent check on that, right? How can we see, based on the data we know about the environmental justice communities, about the demographics, about the environmental impact, what are low risk and high risk communities? That can give us a check. Another one is to make sure that sustainability employees and environmental employees get to try out and play with these tools, see if they're useful for them. How can it benefit and augment their own workforces? This is not an issue of replacement, but how can we make sure that a really vital function of our organization has access and can benefit from a lot of these emerging and like cutting edge tools. Oh, Dave. So I'm so sorry. I think I ran through that and no one interrupted me. Okay, well, we have a good amount of time for Q&A now. That's what I get for listening to like Viking soundtrack music on my commute. So questions, this is cool stuff. I know I highlighted some of its challenges, but you got one example of how at our facilities level operations, we're making sure to prioritize and develop projects that target and benefit these communities. That's one example, but obviously there's others. Yeah.
Does the Inflation Reduction Act kind of help with the funding for
Yes.
these initiatives?
Yes, so we've applied for a number of grants and so far most of those have been successful and that has been a huge funder. Yeah. I will say though, just to add on to that, these are obviously subject to political forces. Some funding opportunities are more reliable than others, right? So when we see now with the election cycle, some of these might be more tenuous. So the EPA for some environmental justice funding has actually they were planning to renew it maybe in December. And then we talk in January and they're like, it's not actually going to be renewed this year. Other opportunities like Clean School Bus, it definitely is. That's more reliable. Yeah.
The EJ screen that you had mentioned.
Yes.
You encouraged companies to get their data. Does the EJ screen provide that data? I mean,
EPA provides
pinpoint
that.
the
It's public.
facility? Okay,
So how it works is that you have your facility's addresses.
right.
So you could cross-reference it. Yep. And you're able to usually export it as well to Excel. And so you can have a local set. It is updated regularly. It's based on census tracts, which is like a interesting measure, but that's something that you could use publicly and available. Consultants will try to sell you their special tools to compare these, but you can go and get it for free. Apologies to any consultants in the room. Yeah.
So other than like, obvious manufacturing sites and maybe some service centers, how does Cummins decide what other communities are actual stakeholders?
So we have products, we have facilities, and we have communities. So we've covered facilities, for example. Products has to do with where are these products being used. So maybe you see that a lot of your products are concentrated in a geographic area, and then you notice that that's also an environmental justice community. It's a low income community. That's one way of looking at, okay, so that means I need to talk to my customers or partners in this area who are operating these products to see how can we work on reducing emissions. That could be something like dynamic operation. When you're operating through, let's say like a state, let's talk about Indiana, maybe you're going north to south. You pass through some low income communities, but you also pass through some like just open fields, not low income communities. Some more populous, like there's a lot more people, and some really not populous
You're
areas.
talking just transportation.
Sorry, yeah. Yeah, do you mean broader than that?
Well, no, but that's pretty difficult. to measure.
It is very difficult, yeah. So, but it's increasingly required to measure your emissions from your products and operations. It wasn't a couple of years ago and that's changing. But yeah, for transportation, it's very difficult. But how do you operate your vehicle so that maybe you're emitting less in those areas that are population dense or low income? And then maybe you operate more efficiently in other areas. That's one just example. And then the third leg is communities. So that's existing community work. So with Cummins, we have different community programs just to provide community grants. How do we make sure that we look at when we have applicants, for example, we make sure that those who are applying for projects that either lower emissions or even like a Boys and Girls Club project for some sort of fuel efficiency project or electric power gen microgrid project, for example, for grid resiliency, make sure that those are prioritized for areas that are low income. Beyond transportation, I haven't given it much thought. Yeah.
Can you give an example?
Can you speak up a little? I'm sorry.
Sorry. An example of a project you've done recently, either with a branch or just some kind of idea for completion, maybe.
Yeah, most have been fleet upgrades. So that it is transportation relevant. So Boys and Girls Club replacement and upgrades for their fleet to move kids around to something that's low emission. Another one that was a major one that our business development team worked on was in New York, where they won a $31 million grant with EPA Clean School Bus for school districts to upgrade their school buses with Cummins powered but clean fuel vehicles. So that was a big one. Other ones include things like workforce development. How do we start including things like maybe at our tech centers, teaching people more about sustainable operations and management for CDL license training, or having to do with maybe electrification more generally and grid support for microgrids. Like one in Texas that we're working on right now has to do with microgrids. And that's important because Texas had issues with grid resiliency. But those are examples in the power gen space that are more focused on grants like from start conception through application. And then we've For some of these, we've heard back, for others not. Others include products, for Accelera, for example, which you'll hear more about later, for things like electric motors or EV kits. Those are also projects that were, grant funded, but specifically to the benefit of communities that are low income, because the sites at which they'll be manufactured were located in low income communities. And we made commitments that we would be employing and training people from that community, as well as adjacent communities. Yeah.
So are communities reaching out to Cummins, or is Cummins?
It goes both ways. Where we already have existing partnerships, we've had some communities reach out and be like, hey, we know you guys are working on this. What else can we do? Is there a way for us to work together? Because we might not have resources to apply for these grants. It's a lot of work. Is there a way for us to work together to get a grant on this? Other times though, we look at where our sites are. So we put up, hey, what are the top 5 sites where we're operating? We have a high impact or footprint, but they're also EJ communities. What are community groups in that area that we can connect with? And that's a more proactive approach. It's more limited. It's actually literally just top 5 at this point. Anyone else? Yeah.
I was just gonna say, great presentation.
Oh, thank you.
Interesting. And for other folks in the room who may not have heard from IDEM before, we do have an environmental stakeholder inclusion program. So we have 2 ESI coordinators in the state that are working for the agency in our Office of Program Support. I think they've been on board now about almost 2 years. So if you're interested in knowing what we're doing, we have information on our website. You can reach out to those, one or both of those ESI coordinators, and we'd be happy to, have conversations with you guys to in this.
Identify partners. Yeah.
Yeah.
That's awesome.
It's where they're doing, very targeted outreach and different communities across the state. So.
Yeah, that sounds great. There's also, if you want to get an idea of what it means to be community-led, because that kind of work can be very difficult and time-consuming. There's a collaborative problem-solving model that the EPA has put out a couple of years ago, I think. It gives you step-by-step what they want to see when you're applying for funding, but it's also just useful to take as a guide. And the other thing I would flag is that when we talk about the environmental justice risks for enforcement, for example, I think it was BP and Whiting that got a really major, like $5 million EJ-related fine. That's increasingly becoming common. So the DOJ actually put out a list of all of the cases that they've enforced so far in the United States. You can go through and see that. I'd recommend that you read their enforcement strategy for their KPIs and for their past successes diligently. I bring this up because it was in Indiana, so it might be relevant. But also that a lot of environmental departments, like Department of Environmental Affairs in different states, are also starting to adopt something similar. So I know that's the case for Minnesota. Right. So when we were looking at our environmental justice risk mitigation framework, like how we're going to manage these risks, that's a guide. That's the starting point. What are they looking for in defining as risks? Where is the highlight right now? What are the hot spots that are already brought to the attention of the Attorney General? And then how do we make sure that we're ahead of the curve and responsive to those types of challenges? But I'd encourage you to take a look at that. They have a really good example on their website for Minnesota. Any other questions? It is a commitment. People are better because we're there. I do believe that, but I do think it's really important to start thinking concretely about how much better are they and where are they actually better. And so I encourage you to do the same, and please feel free to reach out. You can find me basically anywhere on the internet and on your agenda, and I'm happy to talk more. Thank you.
So one of the last presentation for today, you might have heard in the news that Cummins kind of spun off part of our organization focusing on sort of future technologies into an organization called Accelera. So today we have John O'Brien from Accelera, who's going to talk a little bit about what that is, what it means, and some of the products that we're launching going forward. So I'm going to turn it over to John.
Great. Thanks, Amanda. Thanks, everyone, for coming to Columbus on this beautiful day. You're all from Indiana, so you should be used to this anyway. So one small correction, we didn't get spun off. SEC probably wouldn't approve of that kind of language. So we're still part of Cummins. We're basically one of our Cummins business units. So yeah, I work in Accelera in our e-mobility division. We'll get a little bit into some of those details. Real quick background on myself. I'm from Cincinnati. Went to Kettering GMI up in beautiful Flint, Michigan. for undergrad, worked at GM through that and after in manufacturing over in Dayton, Ohio. Went back to grad school at University of Michigan, focused on basically powertrain development, engine development, things like that. Worked at the EPA where I got my first taste of hybrid. So that was a hydraulic hybrid system that they were kind of working. It was a research division up at the National Vehicle and Fuel Emissions Lab in Ann Arbor. Came to Cummins 16 years ago. Have been involved in electrification basically from the get-go. I like to say I started off on the engine side of electrification, which is kind of confusing, but did hybrid work, engine optimization for hybrid, electric accessories, engine start-stop. Did a stint over in the UK doing some power electronics development. Came back to Columbus, where we led our first what we call VPI, or a production program for our first BEV battery electric vehicle program. So, and now I've got all of our powertrain engineering work there. So, got a few patents in the area. This is a very fruitful area for IP. So, pretty much everybody you talk to in our division has lots of patents. So, on to Accelera. So Accelera, like Amanda said, it's a new kind of business unit for Cummins. Basically, maybe you've heard this morning about our Destination Zero. That's kind of our overall Cummins direction. At Accelera, we like to think we are zero, right? So we are only zero emissions technologies. And so our mission is to kind of accelerate that shift to net zero by pursuing all these, like whatever the most promising path is. And I'll talk about our portfolio. There's no one silver bullet, as with everything. And so again, I'm from I'll get back to that. Just some stats we'll throw up here. We got 2,000 folks now working in Accelera. That's a collection of different folks from both kind of Cummins and our different acquisitions over the years. We'll talk more about that. 70 years hydrogen experience. It actually doesn't sound that impressive. My team alone, I think we have like 400 years of combined electrification stuff. But at least going back to 1995 is where our Hydrogenics started off on fuel cell and electrolyzers. Just like Cummins, we are across 190 countries. That's really big for, again, making this sustainable, right? Getting products out there and advancing that adoption curve. 1.5 billion miles plus driven by our electric vehicles or vehicles, including our electric components. That's probably ticking over close to 1.6 already. We're doing about 5 million miles a month, I think, something like that on average. 600 electrolyzers. I'll get back to what these technologies are. People aren't familiar. And 3,000 fuel cells deployed in the field as well. So how did we get there, right? So Cummins, diesel engine, natural gas, power gen. How did we get there? So for about 10 years before 2018, we were developing hybrid, developing plug-in hybrid, developing kind of full BEV system controls, things like that. And so that was kind of in the past. In 2017, 2018, we started our kind of acquisition spree, right? And so these were very targeted, but Gramo, which was a low voltage battery supplier out in Talent, Oregon. In the UK, we acquired part of Johnson Matthey, so Johnson Matthey Battery Systems. Very soon followed by EDI, which is a small startup in Silicon Valley. We then moved on kind of in 2019, 2020, started our hydrogen path. We acquired some solid oxide fuel cell. We dabbled with solid oxide fuel cell in power gen and kind of our power systems team over the last 10, 20 years before this. We acquired that company. Hydrogenics was a big one. So they were doing fuel cell, so PEM, so I'm blanking on something exchange, proton exchange membrane, fuel cells, and also some electrolyzer experience. Formed a joint venture with Sinopec in China to really boost that hydrogen generation market and work. More recently, back in 2022, one of our biggest acquisitions, the biggest acquisition was Meritor. So they did axles, brakes, but then from a Accelera side, it was electric axles, so e-axles. Soon followed with another acquisition of Cummins Commercial Vehicles, Siemens Commercial Vehicles. They developed, again, traction motors. So those are the things that actually push the vehicle down the road. And then more recently, we changed our branding. So we went from, I think we were called New Power at the time. We kind of went through a few different internal names here, but we went to this Accelera again to kind of say, hey, this is serious about this. And this is a team that's focused on that zero emissions technology. And then again, some big news here. This was I think it was a $750 million investment in a joint venture with Daimler, Daimler Truck North America and PACCAR to do battery cell production in the US. And we announced the location of the factory in northern Mississippi, just outside of Memphis. Sorry, I don't know my geography for Tennessee, but right at the border there. And that's going to start production, I believe, in 2027. And that's a huge plant, and that's a really big advantage for all the partners involved. Just a little footprint, where we are in terms of Accelera. So obviously, Columbus, Indiana, West Sacramento, California is where a lot of the fuel cell work is done. Gridley, they're building electrolyzers. There was a big announcement, I think President Biden did last year. Troy, Michigan is where we do, where Merida was based, where we do e-axles. Malta, solid oxide fuel cell in Ontario, battery development in Milton Keynes and in Columbus. Again, fuel cells, electrolyzers, motors in Nuremberg, and then various activities in China for Accelera. So, and sorry, interrupt me whenever you want for questions. I tend to just go on, so stop me, yell. So get a little bit into the portfolio. So what are these technologies? Is everyone familiar, or is anyone familiar with electrolyzers, fuel cells? Okay, I'll try to make it a little basic then. So electrolyzers, basically, if you remember in high school chemistry class, if you put an electric current through water, hydrogen and oxygen come off. This is basically an industrial scale beaker with a couple wires in it. A lot more complicated than that. But basically that is for production of hydrogen. And so that's for both hydrogen as a fuel, but a lot of the applications are hydrogen as a process, like as a process feedstock, right? And so today, you make hydrogen with, reforming methane and lots of different other, coal reformation, things like that, which is very high CO2 output. And so this is basically to get to, obviously if you're using clean energy, clean electricity, so hydropower, things like that, you can have this be green hydrogen. So again, trying to get cost competitive. With all of these things, you'll see a common theme is how do we get costs down and how do we get efficiency up? So that's just the name of the game in terms of making these all these technologies feasible kind of in the mainstream. Fuel cell. So fuel cell is kind of opposite of a electrolyzer. It takes hydrogen, breaks it up, puts out water and puts out water as exhaust, and then hydrogen and oxygen, water is exhaust, and electricity as a byproduct or as a product. And so this is basically a chemical battery. Is a chemical battery. This is a hydrogen battery, for lack of a better term, I guess. But basically, you can use this to power electric drivetrains. And so I'll show you some examples here in a bit. But we can do mobility, so kind of mobile applications, trains, trucks, buses, things like that, and also stationary power. So a lot of the solid oxide fuel cell work that we did was really focused on stationary applications, so power gen type of applications. So those are kind of two groups within Accelera. And then we recently kind of reorganized and focused on e-mobility. So that's again more what we would call automotive applications, so mobile applications, trucks, equipment, different things like that. And so we have three product lines. One is a battery product line. We've got our different technologies, different chemistries for batteries. We use NMC cells. We use LFP. So NMC is nickel, magnesium, cobalt. LFP is lithium iron phosphate. And then we're actually working on the next generation, which is LMFP, which is lithium manganese iron phosphate, which basically means you can get more energy into the same package battery, and it's cheaper and it has more life. So that's the battery line. We built our first battery over in Plant 1, which is across the street that way, I think. But that was kind of symbolic because that's where Cummins started as a diesel engine manufacturer. And so we built our first in-house developed battery over there. And that's the base of manufacturing operations for the foreseeable future. Traction product line, again, that is electric motors and electric e-axles. So an e-axle is basically just a traditional axle with a transmission and a electric motor built into it. So that team also does power electronics. So power electronics are the components that take your power from either a battery or a fuel cell and convert it to AC. So DC and AC takes that DC power and converts it to AC power and controls your motor. So controls how much power you have, speed, torque, etc. And then my product line is on the powertrain side, and that's basically taking these components, taking third-party components, and putting them together with supervisory controls to provide a complete solution for customers. So basically everything that you would need to make a vehicle into a BEV, that's what my team's development. All right, I'm going to pause there. A, to catch my breath, and B, see if there's any questions. Yes.
Yeah, on electrolyzers, I mean, hydrogen's the main product, but is oxygen taken off as the byproduct and used in industrial applications?
No, I don't believe so. I think the main thing is capturing the hydrogen. I think it's just released, but I'm not 100% sure of that. I'm not a.
But it's taken off unimpaired.
It is. Yep. It is produced as part of that process.
Integrated with the industrial operation if you had need of it.
Yeah, we work with companies like Air Liquide and what's the Air Products? I think it's called. I think that's the U.S. And so they may very well, they have bottled oxygen and things like that. So they might as well do that.
Is the fuel cells that work? Is it mainly hydrogen as a feedstock? I mean, coming in, but is it like methyl alcohol? Is that another fuel that could be sent through?
So ours are pure gaseous H2, so hydrogen. We actually are. There is a Cummins joint venture with a company called Entrox. I'm like 99.5% sure that's all public. I think that was like a year ago. So if you didn't read about that, then I didn't say it. But they're to focus on hydrogen storage, right? Because that's a key technology. You need to be able to store hydrogen. And so you're looking at basically trying to raise the pressure at which you store it means you can keep more hydrogen on board and increase range, things like that.
Would a methyl alcohol, is that a fuel that could be used in fuel cells?
I think that would require reforming. Right, and they do have onboard in the past with fuel cell vehicles. They've had onboard reforming of things like they've used almost any kind of feedstock you can peel hydrogen off of, right?
Sure.
And so it's just how much energy does it take to do that, and what are those emissions products? And so it's and how much of a chemical lab you want on your.
So you look at efficiencies on the fuel cell. I mean, what is the typical efficiency, say, for a hybrid application?
So overall, I can't quote exact efficiencies on this, but if you compare it to like an internal combustion full powertrain, because you have higher efficiencies, at the electrical components, like less conversion efficiency there, versus kind of your combustion efficiency, it's better than that, but I can't quote any numbers off the top of my head, sorry. So
it's going to be higher than what an internal combustion engine would be.
Yes. Yep. Again, one of our buzz things is it all duty cycle dependent. So when you ask what's the range on a battery electric vehicle, it's all duty cycle dependent. So yeah. Okay. So I think maybe you talked about the 2050 plan 2050, and so we like to think that we're delivering those sustainability goals today, right? With our products, right? Contributing to Cummins things. So there are a couple things here I'll talk about. We'll go back on this a second. So really we're focused on how do we reduce or eliminate kind of those point source emissions from vehicles, right? So how do you take that emission source out of, a city center or out of a congested area, and provide kind of zero emissions, transport, goods transport, e-mobility, things like that. And so we can't just do this alone, right? We've got lots of customers out there. We've got lots of our commercial vehicle customers. So I'm going to highlight one. It's one that my team works on quite a lot. We worked on for a number of years. That's on our school bus product. So I've got a video here. Hopefully this works. I don't think there might not be sound, but the sound is just some background marketing music, so. But it's just a minute. I actually did the score myself. That was way too upbeat for my presentation, so I probably should have kept that for the end or something. So you saw the number 1178. I think we've probably added another 500 to that since then. But just as kind of a data point here, taking 11 or 1,000 ICE powered school buses and replacing those with BEVs, that reduces carbon emissions by about 10,500 metric tons. Again, folks might be familiar kind of with what that means in terms of relative, but equivalent emissions would be coming from saving or burning 1 million diesel gallons of diesel fuel. Because we don't all drive diesel vehicles, that's also equivalent to charging 1 billion smartphones. That's a fantastic question. I don't know. Sorry, I'm not sure who asked that question, but yeah. I can find out. That's also the same amount of carbon sequestered by planting a lot of trees, 175,000 trees. So, but school bus is not the only place we're operating. So that's kind of one of our larger volume customers. It's a good application for BEV and for today's BEV technology. Pickup and delivery, so medium duty trucks. That's another one we're getting very close to getting to market on. Class 8 trucks, we've got one of the larger OEMs in the US running BEV Class 8 trucks for deliveries. Terminal tractors are a really good application for BEV. It's kind of a captured area or the port ones versus the ones that drive between on the road ones. But basically it's a captured fleet. You can do opportunity charging. It's low speed, high loads, things like that. Transit bus, was our first foray into BEV. So we've had transit bus in production for about 5 years now, mainly with Gillig out in Livermore, California, but they are all over the place. And then we've looked at off-highway applications. This particular one is a low voltage, a 48 volt hybrid, or not a hybrid, 48 volt BEV. Most of our systems run at like 650 nominal voltage. Again, that for the power required in commercial vehicles, that's what you need. Highlighting a few of the fuel cell applications. So passenger train, we've got some of the world's first passenger hydrogen powered fuel cell passenger trains running in Europe. Class 8 trucks, we've had a few different projects with OEMs there. Transit bus, we've had also a few development programs and looking at these lots of different applications. And I mentioned the solid oxide fuel cell and the stationary power. And an electrolyzer, again, we're talking like megawatt scale electrolyzer development. And again, that is, the real push there is to get the cost of the systems down, get the efficiency up. And so, driving up scale in the building blocks is key for that. But basically to try to get that cost down to competitive to these more, these dirtier kind of production techniques for hydrogen. So I think that's all I had. Got a few minutes for questions. Yeah.
Are there any specific schools, like school buses that you can name that you guys have done work for already?
Yeah. So right now we are really deep partners with Bluebird. And so there's one in one in town here. We have one electric school bus running, lots in California. Yeah, I think 30 states we have school buses running in, things like that. So, maybe I'll bring up something. I don't know if anybody had this question, but I think you guys were talking about circular economy and things like that, circular, that life cycle part, right? One of the challenges we have, especially on battery, is materials, right? At the beginning of life, where do you get those materials, right? So cobalt, lithium, again, is plentiful and there's crust. How do you get it and how do you do that environmentally and economically? So that's one kind of thing that, again, the whole industry is wrestling with that. We typically work with our suppliers and make sure they have sustainability plans, that they are, they're watching after those kind of supply chain things. And then on the other end of the battery spectrum, the other end of its life cycle is disposal, right? So what do you do with the battery after it's kind of worn out? So a battery over time degrades, and so you lose range over life. That's just kind of the nature of the battery. I think everybody's experienced that on their personal electronics and such. So basically, looking at second life, like how do you use batteries once they don't meet their requirements for mobile applications anymore. So when they don't have the range required to meet the duty cycle, what can we do with them? Today we recycle, right? There are many, there's a few kind of large scale lithium ion battery recyclers. So we don't toss it in the landfill or anything, but trying to look at what's a more sustainable use for those batteries. So there you go. Spurred a couple of questions. Sorry.
What's the lifespan of those batteries?
So we warrant the batteries. It depends on the application. Again, depends on duty cycle. But like 6 to 12 years is what we expect on those batteries. That's for kind of NMC type batteries. Things like lithium iron phosphate LFP batteries have a longer cycle life. So they can
Climate,
be,
terrain, all make a big difference in this on the lifespan then?
it does. It makes a difference in terms of the throughput. So the energy consumption that the system is using, right? So if you're running in cold weather, sometimes you have to have, I think everybody's seen the stories about, BEV cars, electric cars out there. And when it gets cold, they need more heat, more energy to heat the cabin, things like that. There are ways we can work around that in terms of preconditioning, in terms of some more advanced thermal management systems. So we're working on trying to narrow that temperature and climate type of impact. And then terrain, just like any other vehicle, if you're going uphill, you're using more energy. But with our systems, right, we have recuperative braking or regenerative braking. So when you're going down the hill, you capture, 80 or 90% of that back into the battery.
Is there any type of alternator or anything on there to help generate?
So the traction motors, they basically act as motors and generators. So they provide propulsion torque out, and then they absorb torque when we command it to absorb torque. So that one electric machine acts as both. Sorry, you had one back there?
Yeah, for transit buses, is there a driver routine or a couple of drivers deciding when to go battery versus either fuel cell?
It's basically range requirements, right? And so from a power perspective, the traction system, as long as you're providing enough current and enough voltage, the traction system you can spec to meet whatever duty cycle you have. It's just how long you have to do that. And so you can only fit so much battery on. So on a typical transit bus, right now they're up to, in North America, they're up to about 600 kilowatt hours per bus. And that typically gets them through like their one shift operation. Now, some of the bigger cities, they do like 24-hour transit operations and things like that. And so, but around the ones we have, again, I think it's up to about 600 kilowatt hours, and that meets the need. But if you have different duty cycles, like more commuter type routes, that's where fuel cell comes in. And again, it's refuel time, right? So we're at, less than 2 to 3 hours has been our kind of market target right now. On transit bus, we also have opportunity charging. So pantograph charging, induction charging. So like during a route, you can basically stop at a charging point and gain 20 miles of range and make it around your cycle a few more times. So it's really kind of an infrastructure versus range versus duty cycle. I don't know if that. I should be a politician. I'm great at not answering questions, so. I'm glad I answered that question. You?
Like, you kind of talked about it, when you answered the last question, but with the school bus, that's a BEV. I was just curious, like, how many hours on a full charge would it typically run before it needed to?
So, on their current systems, we can do like 1 to 150 miles, 150 to 100 to 150 miles.
Okay.
And so again, for a school bus duty cycle, that's running in the morning, running in the evening. One unique thing we have on our school bus, because of their usage case, where they have a maybe 2-hour run in the morning, pick kids up, drop them off at school, and then another one in the afternoon. During the day, if you go by a school bus depot, it's usually full during the day. And so what we have is V2G technology, so vehicle to grid. And so with that, you can plug in the charger and you can actually use some of that battery energy to power your bus depot or power, put energy back onto the grid. So that's another kind of sustainability thing. Not all applications can do that. Like any of our applications, we could do that, but it just doesn't make sense in most. A transit bus is running all the time. And so it's not going to stop and use extra energy that it didn't have put in there. But a school bus, you typically have margin on how much energy you have. And so you can use that extra energy and put it back onto the grid. And so, from a peak shaving type of standpoint. So.
Do you get any pushback from these companies, like not willing to switch over to electric because it's maybe cost or just not willing to change?
Yeah. I mean, there's a lot of end customer pool right now. A lot of that's driven by availability of funding, right? So an electric school bus, it is more expensive than a diesel school bus by a couple $100,000 maybe. Yeah. And so, but like VW funding, and that's not going to last forever. And it's amazing it's lasted this long, but so different funding sources, government incentives, things like that. That's really pushed on transit bus. They do any single, they can probably sell every electric vehicle they can make. They're kind of supply chain constrained right now. And again, that's just based on sociability, kind of those type of priorities that municipalities have, things like that. So, on pickup and delivery, we're working to get to kind of diesel cost parity. We have to get there a lot faster because there's not those government incentives, right? It has to stand on its own, total cost of ownership, things like that.
Are you guys using all these technologies here in manufacturing with your terminal tractors and all that?
We are not actually. We're working on a project. There's some internal funding for 2050, our destination 2050, where we want to switch over operations, things like that. And so we've been working with some of those groups to figure out how we can get some BEVs into those, some of our kind of inter-facility transport, things like that. Yeah. I don't know if other places in Cummins are adopting, more pass car kind of utility vehicle type of things. Okay. I think I'm 2 minutes over. So thanks a lot. Appreciate everyone's time.
That concludes kind of the in-person meeting part of the day. So the next part is the tours. We had thought that this was when the storms were going to be. So we have modified, because one of the part stops on the tour is a separate building. So we had kind of modified our tour plan. Of course, now maybe the sun came out, but we're going to stick with the modified plan because that's what we worked towards yesterday. But so we'll start the tour in a little bit. But before we do that, we wanted to have two people talk. One of them is Paul Gleckner, and he is our director of the laboratories. So he'll give an overview of the laboratory side of the building, and then when we do the tour, we'll just walk through. You'll see it, I think, but you'll hear the information about it in here. And then after Paul speaks, then Matt Abdallah will talk about the battery test cells that we won't go outside to see since it's storming now when it was supposed to be storming. So, Paul, are you ready? Do you want to, I have Paul's presentation.
Okay, great. Okay, good afternoon, everybody. I'm Paul Gleckner. I am the director of our R&T Applied Mechanics Laboratories, and also director over our laboratory operations for corporate research and technology. And so I think this morning, Amanda covered kind of the whole view of the CTC site, talked about some of the work that we do in engine operations and test cell operations. This is kind of the counterpart to that. This is just spending 5 or 10 minutes to talk about what we do in the research and technology laboratories also. So. The right buttons, there we go. Yeah, I'm a lab guy. I gotta make sure I hit the right buttons. So the corporate research and technology labs, these represent a broad range of different technical disciplines. And so what makes these part of corporate is that these are disciplines that cover a broad range of our business units and also have very deep technical depth in these. And so, for example, if you look at something like metallurgy, right, that applies to our engine business unit, it applies to Accelera, it applies to power systems. It's a broad functional area. And so we have these disciplines and things like material sciences, applied mechanics, noise and acoustics, advanced manufacturing, fluid dynamics, controls, those kind of things. And then the other element, like I mentioned, is that within each of these, it's very deep technically because we're part of corporate R&T. And so in many of these areas, about half the staff are PhD level engineers. Okay. And so we do a lot of work to basically provide product development support from a corporate level. So if there's business units that are developing something and they run into a new, unique, or difficult problem, they'll often come to the corporate laboratories to try to work those out. We also support the new research and technology initiatives. So a lot of the things that you might have heard earlier from today, either in new engine development with some of the agnostic fuels that we're looking at, or in the electrification business units, with Accelera, we're looking to see how our disciplines can move forward to keep up with what's being developed in those areas. And then also, since we're on corporate, we serve as the global competency centers in these disciplines. So each of these disciplines, like applied mechanics, there's actually a network of about 15 or 16 applied mechanics labs globally. And so part of that network, the corporate group, which I lead, kind of maintains that network and maintains the connections that go on through there. And so with that, our main philosophy is, to have quality in our work. So we don't want to pass on crappy results. But agility and flexibility are really important for us in the work that we do, simply because of the evolving business needs that we're having strategically as a company. Okay. So last part is just a little bit of how we operate and what our focus is. And so I mentioned, just now, quality, agility, and flexibility are extremely important. So as laboratories, what we do is we're very deeply engaged with the different business units. And so we do things like voice of customer. We have ISO 9001 quality processes that we follow, simply to get out there and sense what the businesses are needing and be able to be flexible and move in that one. Okay. The next is developing our measurement methods to support these businesses, kind of driving from what we learn. And so, one of the examples I have here is we started to investigate the use of fiber optic distributed sensing in battery packs. So new technology, using fiber optics, trying to apply it into unique problems that are in this evolving area of the system. Then finally, the other is that we're not just keeping, this stuff that we develop right internally to ourselves, but we're also trying to get the technology transferred out to the other businesses. And the example that I've got on this is that we've spent a lot of time in our material science group in non-destructive testing to explore X-ray CT scanning as a tool, right, for research. And what we found in working with the Accelera people and working with fuel cells and hydrolyzers is we can detect hydrolyzer faults in the plates using this technology, which when the plants learned about that, they got very interested about, can we use this as a quality control process in our manufacturing? And so that's an example of taking what we've learned and transferring it out to our business units. Okay, so open for any questions that people might have. Okay, great. Thanks.
Well, thank you very much, all of the common speakers and the hosting. This will conclude the meeting portion. So our online members, we appreciate you being here. Are there any questions? Anybody leave any questions in the chat?
I didn't see any.
Fair. The hit or miss for that. Okay. But feel free to, if you have questions on the survey or reach out to any of us on the committee. So we'll close that part, and then I think you have items for the tour and all those details.
Yeah, so we'll break into groups for the tour. We do a kind of a program for tours, so there's no special personal protective equipment that we'll need. We're going in areas where we'll be fine. Sit close to